we're starting a scientific method lab. It's called Plop Plop Fizz Fizz, and you're gonna determine how quickly Alka-Seltzer dissolves in 5 different temperatures of water. You are going to do the timing yourself, and you're gonna measure the temperature, or you can record the temperature that I've measured. So for instance, this is the room temperature water, and it's reading at, what do you guys see? I'm not gonna tell you, hopefully you can read it. So we're gonna start with the hot water. So here I have some Alka-Seltzer, so make sure to put your timer on when I start the Alka-Seltzer. Alka-Seltzer, well, first of all, let's record the water temperature. Whoops. And it is 79.1 degrees. Whoops, I'm not going to tell you that. Okay, let's see how long it takes. We are going to go until it stops fizzing, actively fizzing. And that is done, I would say. Now let's try, is that how I do it? The warm water, like that? We're gonna try the warm water. There's your temperature. And again, we're gonna wait till it actively stops fizzing. And that looks like it is done. Now we are on to room temperature water. Okay, there's your reading for room temperature water. I'm going to put the Alka-Seltzer in now. And it looks like it has stopped fizzing. Okay, we are going on to the cool water. The cool water is that. Hopefully you can see it. Putting the Alka-Seltzer in now, so start your timers. As you can tell, that one is going a whole lot more slowly. Because of that, the cold water, the ice water Alka-Seltzer may be on a separate video. How long have we taken, do you think?
350, so.
Oh, we're good. And that is... just about done. Okay, now on to the ice water. Here we go. Ice water is never mind, you record that. And this is gonna take longer, we would think. The reason that the ice cubes are still in there is to keep the water at a constant temperature. In theory, if I had that mostly filled with ice and some water, we would be down at around the melting point of water or the freezing point of water. They're the same thing, 0 degrees Celsius, but it's not full of ice, and the ice is actually melting as we watch it. So the water is getting colder over time. Whether it would eventually go down to 0 degrees Celsius or not is open to question. Not with that much ice in it, I don't think. It might get down to maybe 4 degrees. If you look at the Alka-Seltzer, if you can see it at the bottom, it's just not doing too much. It's kind of going bloop, bloop, bloop. When we do this in class, everybody says, you should have had us do this one first so we knew what we were doing, because this one is the easy one to do. But as you can see, it's still bubbling away. It's just, the tablet is probably, half its thickness, a third of its original thickness. It's beginning to break up enough to float. The reason we're not stirring this, which would make it dissolve faster, is so that we're doing all of our experiments with the same conditions. The Alka-Seltzer is at the top. There's still a little bit of it left. And it looks pretty much finished to me. So we'll call that done. All right, so now you've got 5 sets of data. You have time and temperature, and you have a graph to make. Good luck.